Greetings, ladies and gentlemen. It's time for a little lesson on dilating figures. So first, turn to this page. So we are going to just do some dilations. So the word dilate, if you ever gotten your eyes dilated for like an eye test of some sort, that means to like change its size. Usually like you get it bigger, like your pupils dilate, that means it gets bigger. Well, dilations in mathematics are very similar. Often things get bigger, but things can get smaller. But yeah, we're diving into a little bit of geometry here. When you dilate a figure, you do need to use a center and then some sort of scale factor. Say you want your shape to be twice as big, then the scale factor is 2. If you want your shape to be half as big, then your scale factor is 1/2. The center is just, well, what do you dilate from? Like things get bigger from a point or smaller towards a point. And so you just have to have some sort of center and a scale factor. I'll often call them growth factors because I keep switching back and forth. So let's look at this example here. Let's say you have this lovely triangle here, and I want to dilate by a factor of 2, and it has a center at 0, 0. Well, in these first two examples, we're just going to use the fact that you can take the x and y coordinates and multiply by your scale factor. So like A right now is sitting at 0, 0. If you times them both by 2, you get 0, 0 again. Right, times 2. Get to that thing. So A is actually just going to stay here. So here's our little A prime. B, on the other hand, is currently at 4, 0. So I'm going to take those times by 2, and that's going to give me 8, 0. So that's my new point for B. B is going to get 8, 0. There's my B prime. And then C, hanging out up here, C is currently at 4, 3. I'm going to take those times by 2. Times by 2, and you're going to get 8, 6, so that's where the new coordinates are going to be. 8, 6, it's going to put it up here. Here's my C prime, and voila, there's my new triangle. Ta-da, we've dilated. That's it. That's pretty much it. You make your shape bigger, you make it smaller, you just times by whatever your scale factor is. So take a moment, come over here to example B, and see if you can dilate this by a scale factor of 1/3. Again, our center is going to be down here. And so you can just take all the coordinates here, times it by 1/3, and draw what you get. So take a moment to do that. Alright, let's have you check and see how you did. Sorry, I'm trying to draw as fast as I can. So you got A prime, D prime here, here's C prime. Hold on a second. Yeah. Okay, sorry. I just had to make sure. I was like, I was thinking it was a half. That would put the C right there. But no, it's 1/3. So there you go. There's our new shape. Hooray! Well, that's not the only way you can do a dilation. It's kind of the easy way if your center of your dilation is at 0, 0, or the origin. But if your center of your dilation is somewhere else, then that is not the easiest way. You'd have to like remap where the points are, which is pretty annoying. Another handy way to figure it out is just figure out what the slope is from the center to each of the points, or the change in y and change in x, and then you can times that by the scale factor. So here's an example. So we got our same shape as last time. And our center dilation is here at 0, 0. So we can figure out what's the change from here up to A. Well, this went up 3. And it didn't go right or left at all. So my change in y is just 3. And what you do is you just times that by 1/3. So times by 1/3. And that's going to give me the point where it was here, A prime. Let's do something a little bit more interesting here. We got the point B, which is at 6, 6. Or if you're looking at slope, it went up 6 and right 6. And we're going to take both of those and times by 1/3. Times by 1/3 on top, times by 1/3 on bottom, times by 1/3 over 1/3, which is going to give me 2, 2. So the slope from my center here, I just need to go up 2 and right 2. And that'll give me my point there for B prime. And you can do that for all the points. So D here, it went up 3 and right 3 from my center. So you times them both by a third, and you get 1 over 1. So the point's going to be up 1, right 1 from my center. So there's my d prime there. Once again, these things are kind of figuring out what the slope is, or the change from the start to where the points are, your center of dilation to the points, is easier when your center is not, well, at the center. And so what I'd like for you to do is go to the next part. These are all, you're dilating from the origin, or dilating from the center of the coordinate grid there at 0, 0. So you need to do these dilations. So take a moment to do these dilations. Once again, you can just take the coordinates and times by 3 or times by 1/3 or whatever it's asking for. Pause, do that, and come back. All right, so now we're going to dive into what if it's dilating around a different point. Let's say we got this lovely example here. This was the beginning triangle, just going here like this, and it dilated from this point, not the origin, it dilated from this point here. It looks like it is about twice as big, so scale factor is probably 2 on this one. And yeah, so you can dilate around or away from a different point. Here's another example. Here's the starting square, and it dilated with regards to this point, so everything expanded out from that point instead of expanding out from this point, which would have, like moved the square over here. And so yeah, you can have a different dilation that puts it in a different spot. And this is why we went over, like, how do you figure out if you're just going to use slope, because that's how you're going to manage these ones. So let's go to the next section here. It's got a couple of examples. I'm going to go to example B. So example B here, our center of dilation is at 5, 8, which, if I count correctly, I believe is right here. This is going to be my center of dilation. So C is on there, so C is just going to stay there. It's not going to go anywhere. But all of these other points are away from it, and we need to times those distances, or the slope, or the difference, by this scale factor. So let's figure out from C to B here. It went left 1, 2, 3, 4, so it went left 4, and it went down 1. I'm going to times both of those by a half. So it's going to be left 2, and then down, well, a half. So there's where B prime is going to be. To go from C to D, you just had to go down 1, 2, 3, 4, 5, 6, and cut that in half. So that gives me D prime. Well, to get to A, you have to go down 6, 7. You have to go on 7, and then left 4. You can cut both of those in half. So instead of going down 7, you can go down 3.5, which is here-ish. And then left 4, instead of going left 4, you're going to go left 2. And there's going to be my A prime. So now I can connect these up to make my shape. You don't have to draw all the numbers on there. You just need to get the shape on there. But I'm showing where these things are coming from. So yeah, I guess kind of a most extreme example is from C to A. You went vertically 7 and then left 4. You cut them both in half because that's our scale factor. So down 3.5 from C, and then left 2, give you your A prime. So there you go. If I erase like all my extra, whoa, no, too much erasing. All my extra stuff, you're looking at something like that. So that's what's going on if your center of dilation is somewhere else. I'd like for you to go to example A and see if you can complete this dilation, scale factor of 2. All right, hopefully your looks something like this. Your A is on the center of dilation, so it's just going to stay there. And then you had to go right 3, up 2 to get to C. You're going to times them both by 2. So you can go right 3, I guess from C, you can go right 3 and up 2 again. So that's total right 6, up 4 from A. It's going to put C prime here. And then B is a very similar story, left 3, up 2. So you go left 6, up 4. And they give you where B prime is. So it's going to look something just like that. So there you go. If I erase all these extra lines, erasing all my work, and it's going to look something like that. So there you go. That's what's going on with the dilations. These ones, you got different centers that you use. You have different scale factors, 4.5 and stuff. But there you go. Dilating shapes. Pretty easy.